rise and the consequence of the deglaciation that we're currently experiencing in the Arctic and the Antarctic. So as human-caused climate change disruption progresses, sea level is happening far faster than previously expected. Everything pointing to sea level rise is getting quicker. So here again is a global sea level rise map, and you can see that actually the sea level is rising quite a bit. It's risen 8 centimeters since 1992. Can you believe that? But look at this. Look how quickly the gradient rises there. This is the recovery that we had in 2013 and 14 because I guess it wasn't as hot. And then look, it's off and galloping again. So we've got the high gradient and a steeper and steeper slope with sea level rising. And I think that also is on a polynomial trend line. And we find that global sea level rise is actually going exponential. And we find that every 10 years, it actually doubles. So by definition, that's exponentiation. And by definition, we can't say that whatever we experienced yesterday is going to look like what we will experience 10 years down the road, because it won't. In fact, Paul Beckwith has said that we may be on track for a 7-meter sea level rise by 2070. That is 28 or 30 feet. Can you believe that we would have sea level rise of 28 or 30 feet by 2070? That is really a very stunning thing. But he's done a lot of calculations, and he's been looking at this issue a long time, and he is a scientist. And so if Paul Beckwith says we've got 7 meters on track for 2070, I tend to go by that figure. He is a very steady scientist. So if the doubling period of the ice caps from Greenland and Antarctica hold up, we will see 7 meters of sea level rise by 2070. NASA scientists say that they're worried about the increasing speed of melting glaciers in Greenland, and this melting is leading to higher sea levels that threaten coastal communities from Florida to Thailand. So with that in mind, let's take a look at Florida and what it might experience if in fact there were 3 meters of sea level rise. What we can see from this map is that if there were 3 meters of sea level rise in Florida, Miami would be wiped out, as well as a lot of other coastal communities within Florida. They would be wiped out. If in fact there were 6 meters of sea level rise in Florida, we would see, of course, more devastation, and we would see the sea encroaching on the land more and more. Here is four maps, actually, of sea level rise around the world, and the color that you should probably pay attention to is the darker blue. The lighter blue is up to 25 meters of sea level rise, but I really think we should really only look at the 6 meters of sea level rise for our purposes right now. 25 meters, it certainly will happen. There's no question in my mind that we will have 25 meters of sea level rise in the future, but I don't think it's for a while. So let's look at the 6 meters of sea level rise and see how it looks. You can see around Florida, there's a lot of inundation. Also, Bangladesh is gone, as are parts of India in the west, in the northwest, as well as China in the southeast, and Europe is quite impacted. Venice, Netherlands, you know, all throughout Europe, it's quite impacted. So this is devastating for our culture. If all the ice sheets on Earth melted, and I am not sure that they will all melt, but if they did, this is what our new map would look like. Florida essentially would be off the map. We have about 200 feet of sea level rise wrapped up in Antarctica and about 23 feet wrapped up in Greenland. So that's 220 feet, 3 feet of sea level rise potentially wrapped up in the ice caps. With that in mind, we really have to talk about the ocean, because it is the ocean that covers 70% of our planet. And it is the ocean that is feeling the real brunt and the impact of the increasing carbon dioxide in our atmosphere. This is an upper ocean heat anomaly map, and you can see by looking at this map that the ocean heat is very high in the upper part of the ocean. As well, you can see that it's starting to go down into the deeper parts of the ocean, but you can see immediately the entire upper part of the ocean is anomalously hot. 2002 through 2011 shows extreme global heating of the upper ocean. And this is really happening more in the northern hemisphere, where all the methane is coming out and where all the industry is and where all the land is, not all the land, but the greater part of the land, and the carbon dioxide emissions are as well. So you can see, if you look at this graph, that globally temperatures are on the rise. But what you can also see is that the northern hemisphere, in fact, is getting hotter more quickly than the southern hemisphere. So that's just another way to look at it. This is a northern hemisphere phenomenon starting all this stuff up here. But the ocean heat is going up, I mean, very constantly. Look at this, like since 1980, the ocean has not stopped. It's been on a non-stop roller coaster ride, but straight up. And we find that the ocean is getting hotter and hotter, and that's actually quite terrifying. So in March 14th, we find that there's a very high sea surface temperature anomaly of about 70 degrees right here near New York, I guess, near the Gulf Stream. We can kind of see that the Gulf Stream is 70 degrees March 14th, and it's going straight up to the Arctic. So let's see how the Gulf Stream really affects our life and our ocean temperature and things like that. What we can see is the Gulf Stream, of course, is heating up as it goes through Indonesia and the Philippines, down through South Africa, swings through the Caribbean and Florida area, swings by England and Ireland, brushing them with its heat. And then, of course, when it hits Svalbard, it turns around, delivers its heat, as we saw, to Svalbard, delivers a little bit more heat to Greenland, and then abruptly sinks. So that's kind of like the ocean current and how it's affecting heat in the Arctic. As well, the oceans are getting a lot more acidic than they used to be. That is because carbon dioxide, when it's dissolved in ocean water, effectively lowers the pH of the ocean, and it dissolves into the water, and it turns the ocean water much more acidic. And this is hurting a lot of the sea creatures that are in the ocean. It's causing a lot of death in the ocean. It's causing very abnormal algae blooms, and all sorts of problems are happening in the ocean that we never used to see before. And that is because the ocean is getting increasingly acidic. In fact, you can absolutely track the acidity of the ocean against the Keeling curve of carbon dioxide, and you can see they are 100% parallel, and it is a one-to-one correlation, cause and effect. Emissions cause ocean acidity. Within the ocean, there are these beautiful creatures that give us life, phytoplankton. Most of the Earth's oxygen actually comes from these tiny ocean plants called phytoplankton, and they live near the water surface and they drift with the currents. They give off 50% of the oxygen that we breathe here on Earth. And we find that these oxygen depleted areas are increasing. So there are areas all around the periphery, around the continental margins, and you can see that these are areas that have become dead. There are no fish there, there is no life there, and where there are a lot of humans and a lot of industry and a lot of discharge into the ocean, these areas then become dead.